Okay, so what we're going to look at today is the slope of a line. Okay, so the slope of a line, or sometimes they refer to it as the gradient, it's just how much a line slopes. Okay, now you'd be familiar with slopes, you would have seen slopes before. So how much something slopes. So it's just all about different ways that different slopes or different gradients of different lines, right? So the easy way to get the slope, the easiest way I should say, is to get the rise over the run. So if we were asked to get the slope of this line, we could say that it's equal to the rise, how much it rises up by, over the run. Okay, the rise over the run. So that's the easiest way of getting the slope. Slope will be equal to rise over run. So if we want to find the slope of that line there, it'll be equal to the rise over the run. And in this case, it's going to rise up 2 units. 1, 2. So we can say it's going to be 2 all over the run. And it's going to run across there 1, 2, 3, 4 units. So it's going to run across 4. So 2 over 4, that will simplify down to 1 over 2, because I can divide the top there by 2 and I'll get 1. And I can divide the bottom there by 2 and I'll get 2. So the slope of this line, the slope of the red line there, is going to be 1/2. Okay, so that's telling us how much that rises by. Okay, so that'll be the first one there. So we'll just look at the next one there. So we're going to do something very similar here with this one, and we're going to look at the slope of this line, and we want to see how much that is sloping by, right? So we know we're starting there at 1, 2, and we're finishing there at 6, 5. If we want to find the slope of this line, we're going to have to get the rise over the run again. So if we want the slope, it'll be equal to the rise over the run. Okay, so how much it rises up by, and how much it runs across. So we can see there that it rises up 1, 2, 3. So the rise, which is how much it rises up by, is going to be equal to 3. The run in this case, or how much it runs across, is going to be 1, 2, 3, 4, 5. So the run is going to be equal to 5. So in this case, the slope of our line is going to be a fraction, and it's going to be 3/5. So the slope of this line is going to be 3/5. Okay. So we'll try this one here. And with this one, again, we're doing the same thing. So a slope of the line will be equal to the rise over the run. So I want to see how much this rises up by, and obviously how much this runs across. Okay, so I can see here it's rising by 1, 2, 3, 4, and 5. So the rise in this case will be equal to 5, and the run in this case will be equal to 3. So if I want the slope of this line, I put the rise, which in this case is 5, all over the run, which in this case is 3. And if I use, well, that's top heavy fraction, we could say. So if I want to make that, well, typically, to be honest with slopes, we'd leave them as top heavy fractions, but just in case you want to simplify, that'd be 1 2/3. Okay. So we look at this one here now, and we look at that slope, and we look at the slope of this line here, which is going to be the rise over the run. Okay, and the slope of this line, the rise there is going to be 3, and the run here is going to be 3. And let's just fill them in. 1, 2, 3. Similarly, 1, 2, 3. Okay, so the rise over the run, The rise is how much it rises up by. So it rises up by 3. The run in this case is going to be equal to 3. So the rise over the run is going to be equal to 3 over 3. So that gives us an answer of 1. So we'll look at another one there. And you can see here this one is going to start at 1, 2. Finishes here at, you could say, 7, 8, right? So 7 on my x-axis. And this would be 8 on my y if I had drawn my next point on the y-axis, right? So in this case, this red line, you might notice that red line has the same slope as this one. But let's just see what happens when we get the slope of it. So the rise over the run for this one will be equal to okay. And in this case, the rise is going to change slightly. And how it's going to change is just going to be from here to here. Okay. So it's going to be 1, 2, 3, and obviously 4, 5, 6. Okay, so you can see there the rise this time is going to be equal to 6. The run this time is going to be slightly different. So the run this time is going to be from here to here. Okay, so it's going to be 1, 2, 3, 4, 5, 6. So the run this time is going to be equal to 6. So I'll get 6 over 6. And that gives me an answer of 1, because 6 divided by 6 leaves me with 1. So that's just showing you, you've got two lines of different lengths, but you can see there the slope of both these lines is the same. Okay, so it doesn't matter what length the line is, the slope is just a measure of how much it's sloping by. Okay, so what we look at now is we look at what happens as the slope changes, right? So we'll take this line here and we'll look at how the slope changes. So in this example, you can see the slope for this line. Okay, and we'll just put in the slope of this line so we know what it is. So the slope of this line is going to be the rise and the run is going to be 2. And we can see that there. Okay. So 2. Okay. So that's going to be 5 over 2. The rise over the run. Which is the slope. So the slope is going to be rise over run. So slope. So you can see there at the minute the slope there would be 5 over 2. If I was to bring that down, so let's just say I was to change that, and if I was to bring that to, we'll say here. So if I was going to go from here to, my mistake. So if I was going to go, we'll say from here. So if I was going to go from here to, we'll say there, right? You can see that the slope would be slightly different. And in this case, the slope would be rise over run, and the rise there would be 1, 2. And you can see that the run there would be from 1, 2, 3, 4, 5. So in this case, the run would be 5. So in this case, I have a slope of rise over run, which is 2 over 5. So you can see it was 5 divided by 2, which is 2.5. Now it's 2/5. You can see it's getting smaller. If I do another one there, so we'll just do another one there. And if this slope was to go from here to, we'll say here, or even here, okay? So if I was to go from there to there, you'll see the slope is going to get smaller again. So the rise there would be 1. The run there would be 4. So rise over run would be 1 over 4. Okay, so you can see the slope is gradually getting smaller and smaller. And that is all to do with our slopes. So these are all positive slopes. Okay, so they're all positive slopes. What I'm going to look at next is negative slopes. Okay, so the reason why they're positive, and I'll just put that in the next slide. So this is a positive slope, and the reason why it's positive is because as your x values get bigger, so you can see here my x value there is 5 and my y value is 3. Okay, so my x value is 5, my y value is 3. But as my x values get bigger, so let's go to here. So my x value there is 7, and my corresponding y value will be 5. So as my x values get bigger, as my x values increase, my y values increase. Okay, so that's a positive slope. So as the x values get bigger, and you can see the x value there is getting bigger, the y value is also getting bigger. I'll do another example of that. Okay, so if we just get rid of that, and we'll try another line. So let's just take this line here, and let's bring it like this, perhaps, okay? Or like that even. Okay, so with this line, if I want to know if that's a positive or a negative slope, I'll just look at it, and I'll take an x value. So let's just take this one here, 2. So 2, my x value of 2 maps onto a y value of just over 2, about 2.5, I'd say. Okay, so we'll just say 2.5. Okay, now what happens as that x value gets bigger? As that x value gets bigger, the y value gets bigger, 4.5, we'll say. Okay, so you can see there, as the x value is getting bigger, the y value is getting bigger. It's another example you could say. So the x value is increasing, the y value is increasing. So if you want to know if a slope is positive or negative, you can just check, are the x values getting bigger and the y values getting bigger? If they're both getting bigger, it's positive. Okay, so now it brings us on to a negative slope. So if we know this is positive because the x value is getting bigger and the y value is getting bigger, we need to know what a negative slope looks like. So what a negative slope looks like, okay, is when our line slopes from left to right. Okay, so an example of that would be like this. Okay, or even like this. Any of these are all negative slopes. And what I'll do is I'll just get one there, like start off with this one. Okay, so, and the reason why this is a negative slope is because you can see there that just fill back in these there. So I've got 3, 4, and 5. So let's just fill in our numbers there. So this should say 3, 4, 5, 6, and 7, obviously. And this should be 2, obviously. Okay. So the reason why this is a negative slope is because as our x values, so let's start off with an x value here. So we'll start off with an x value of 2. Okay. So if we have an x value of 2, we want to see what the corresponding y value will be. And we'll say the corresponding y value there is 4.5, just roughly. But what happens as our x values get bigger? So if our x value gets bigger, so we'll increase the x value by 4 and bring it up to 6, right? So we're going to get our x value larger, and we'll see what happens to our y value. We can see that our y value is going to go from so our y value is going to get smaller, and you can see that it went from 4.5 back to 3. So as our x values got bigger, our y values got smaller. So x value gets bigger, y value gets smaller. And that just shows us that to go from left to right, if it's sloping from left to right, if the x value is getting bigger and the y value is getting smaller, then we have a negative slope. Okay. So we'll just look at these 4 lines. So you've got A, B, C, and D. A being this one, B being this one, C being this one, and D being this one. So what I'm going to do is give you a second just to have a look. I want you to know, I want you to find, I want you to tell me whether A is positive or negative, whether B is positive or negative, whether C is positive or negative, or whether D is positive or negative. So if we start off with the first one there, which is A, I want you to be able to tell me whether that is positive or negative, right? So have a think about that. And the answer there for A is that it is positive. And the reason why it's positive is because as the x values get bigger, okay, so 2, sorry, it's not positive, it's negative. So as the x values get bigger, the y values get smaller, so it's negative. Okay. For B, B is this one here. And again, with this one, we can see if that's positive or negative, and it's negative. The reason why it's negative is because as the x values get bigger, so let's just say we started with 3. 3 maps onto 6. Let's say we increase 3 to 6. 6 maps onto 3. So you can see there that as the x values got bigger, okay, so let's just put that in. So as the x values got bigger, the y values got smaller. Okay, so as the x values get bigger, the y values got smaller. We look at C next. And with C, we want to know if C is positive or negative. So we'll have a look there and we'll just check. So let's just start off with an x value of 4. 4 maps onto about 2.5. Okay. But I'm going to see what happens. My y value, so my x value gets bigger. So let's just say 4 turns into 6. My y value will get larger, 5.5 roughly. So you can see there, as my x value gets bigger, my x value is going to get bigger. My y value is going to get bigger. So that's going to give us a positive slope. And the last one there is D, and we want to see if D is positive or negative. Now you should be able to spot it straight away because of the way it's slanted, but just to make sure, let's start off by looking at an x value of 2, gives us 2.5. And as that x value gets bigger, so let's increase that the whole way up there, we'll increase it by 4. So if we increase that by 4, we'll get a y value of 5. So we can see that as the x value increases, the y value increases, so that's going to give us a positive slope. Okay. So that's that. So that's the difference between positive and negative slopes. Okay, so we should be ready to do the first 3 questions there. So question 1, state whether the slope of each of these lines is positive or negative, and I'll just give you a minute to try them. And we'll mark them now, right? So A is going to be positive, B is going to be positive, C is going to be negative, D is going to be positive, E is going to be negative, and F is going to be negative. And just as a side note there, just to give you, like at this stage, you should have kind of pieced this together yourselves. So positive slopes go from this way. So positive slopes will be like this. Negative slopes will be like this. Obviously, you've got y and you've got x. So you've got y and you've got x. Negative slopes will be like this. Okay. So negative slopes they slope from left to right. And that'll bring up questions. If you have something like this, we need to know, is that a positive or a negative slope? Well, if you think about it, the rise over the run. So let's pick 2 points. We'll pick this one and this one. So the rise, how much does that rise by? And it rises by 0. The run, let's just say, for instance, that ran across 3. The rise over the run would be 0 over 3. 0 divided by 3 gives you 0. So this one doesn't even have a slope. Okay. We'll have to leave it at that, guys, unfortunately, right? Because time is up. But I'll upload that video and you'll be able to check.